Ramesh, I have forgotten, are you from SAP background or non-SAP background?
SAP, but I'm new. I mean, I belong to PI and portal.
Okay,
NetWeaver,
okay. NetWeaver portal.
and
Okay.
also PA, so but I'm a little bit of BW stuff. But one more question, Rajesh. So how things are at BW level? I mean, how much expertise is required? That's very much confusing for me at this point. You see what I'm saying?
Can you come back?
So my question is, how much, what level of expertise is required for BW for HANA? So I'm seeing everywhere, I did go through some of blogs and everywhere they're talking about that.
Okay. So when we look at here, so when we look at the job opening front, right? So we have a multiple job openings as a HANA consultant. So we are going to work as a HANA platform, as we'll be working as a HANA consultant. Or let's see if the guy is from BW on HANA, right? So the guy will be working on BW related stuff on BW on HANA. Also a HANA consultant can be working on BW on HANA project. Let's see if I think let's take if we have a project, any of the project, let's take we have a BW team of 5 people, and there will be another 5 people for, not 5, so it should be something 4 people for SAP HANA. So if you have a BW knowledge as an added advantage, that will be added advantage for you.
So you mean to say that team, I mean, you mean to say HANA team will be different, BW team will be different, I mean, or whatever it is, BW and HANA is different, right?
Yes. So there will be like when we go for recruitment also, right? So people there is a requirement on HANA, so they take the SAP HANA guys, and if you have a BW knowledge, that will be added advantage for them. Okay, it's not like you need to completely work on BW, but if you are good at BW on HANA, BW as well as that will be added advantage.
Okay, gotcha.
So when we look at when we look at my current what is that course content, so here we are taking with SAP. If the let's see if the guy is from SAP HANA, right? So we'll be taking the SAP HANA as well as note this the other one. Okay, so we'll be taking the HANA course content as well as we'll be taking 1 week for the guys who are from non-SAP background. So I'll be covering them only 1 week session. If you look at the HANA resume, let me open that. So the guys who are from non-SAP background, so we take only these concepts, only few of them. If the guys who are a little bit aware of SAP BW, so the same class will be continuing with some advanced concepts as well.
Okay. Okay. So my question, right? See, my question, you're talking about all these things, however you do, 7.3, 7.4, 7.5, in BW also 7.5, 7.4, things changed a lot, right? So you will be talking about that?
Yes, not all these things, not this one, not all those things. So
which are applicable to HANA, right?
yes, so we'll be taking 2 weeks of BW on HANA sessions. For first 1 week for the guys who are from non-SAP background, and the other 1 week will be for who are from SAP BW and who have a knowledge on SAP BW can attend that other 1 week.
Okay. So that will be covering in this session, I mean in this content only, right?
Yes.
Okay.
Okay, there is nothing like no additional charges for this. I'll be taking other 1 more week for the guys who are from the SAP BW guys. So that the people can learn, the guys who want to learn HANA, they can learn, or the guys who are more little bit interested on BW guys or who are interested, they can also join with that batch for another rest of the 1 week. So So we'll be covering almost most of the advanced concepts in SAP BW as well.
Right. Okay. So one more question. So how big of deal is this cloud, HANA and cloud? So I mean, do you know people extensively using it, or still it's in a starting situation?
It's still in a starting here actually. So I don't see any clients are using HANA on cloud as of now. So
Okay.
might be people are, most of the clients are going with S4 HANA. So S4 HANA means they're going with simple finance.
Mm-hmm.
So most of the clients are already implemented with the simple finance, and most of the clients are there going with the simple finance. When we look at the simple finance, so we should have a background of SAP FICO.
Okay.
Only those guys can learn, go ahead and learn simple finance. And we have a simple logistics, but it came in last year, but there are some bugs in the product. So SAP is suggesting to wait for a few more months. Should be in the month of September or October. The new release would be coming into the market for simple logistics.
Okay. Okay. I understand what you say.
Yeah.
So we will be seeing the data extraction part, that things coming using SLT and other tools, BODS, and then we will see ETL.
Yeah, all these things will be covering. So we go with the SLT for 3 days. So let's see if there is some issue with the configuration, then we may require one more day, right? 3 to 4 days. And for BODS, we'll be taking 1 week of session. So we'll see how to get the data from multiple tables. If you look at the course content, right? You can see here, for BODS, we'll be working on multiple scenarios, loading data from file, Excel file, and loading data from flat file. And so we are getting the data from flat file and splitting data to multiple targets. And we are getting data from MS SQL and from ECC, and getting data from multiple tables from ECC, and how to get the data from SAP PW as well. So we'll be looking at all these scenarios when we go with the BODS. We'll take almost 1 week for BODS.
Okay.
Okay, and we'll take a 1 day for DXC, and smart data access will be taking 1 day. And when we look at the view, we may take almost 15 days to 15 days for creation of these views. And we have few other topics like analytical privileges or transport. It takes almost 1.5 months for our course to complete.
Alright, Rajesh, that's fine. So when you want to start the real, when I know you are waiting for somebody else also. That's what you told in last session. So do you think you want to wait till some more people join? I mean, you are waiting for them, right?
No problem, we can continue the class. Okay, so people who are coming, I'll have a backup for them for the demo, and I'll join them in our batch then.
Okay.
Okay. Okay, so we are at 7:30 now. So let me take an hour today. So in the last class, right? So we have seen, let's quickly brief whatever the topic we have covered in the last class, right? We have seen the evolution of HANA, right? So when we look at it 1980s, we have only the database server and the client application. And when we look at the 1990s, so we have a 3-tier architecture, which is between the OLTP system, so which is of online transactional process. We have some limitations like we are not able to generate like forecasting of reports or intelligence reporting or analytical reporting. That's why we came up with OLTP system, which is a data warehousing system, which is a SAP BW system. These topics we have covered. And so how SAP HANA has been evolved. So we have seen the BWA, which is the BW Business Warehouse Accelerator. When we go with the BWA, the read performance will be faster. and we have SAP had P star 10, the write performance will be faster, and the live cache, so basically the read performance will be faster when we go for live cache. So this is the diagram which we have discussed how SAP HANA has been evolved in the market. And of this, when we look at the major advantages of HANA, so we have seen that reading data from RAM, right? So let's go with the next one, SQL console, right? So did we cover these things, Ramesh? SQL console and columnar store in SAP HANA?
No, we are not.
We are not, right? So let's continue with this. So I'll be taking the 3 to 4 sessions for basics, and I'll be getting into the system also. Meanwhile, just show you what is the overview of HANA everything. So first 30 to 45 minutes will be going with theoretically, and last 15 minutes I'll be just showing whatever available options in the system. Okay, first theoretical sessions, then we'll purely jump into the system.
Okay.
And you'll be getting the latest version, like SP11 will be the latest version, you'll be getting the access. So earlier we used to get only SP9 or 10, so now we have a latest version with the SP11. So SP12 was came just that's almost 1 month ago. So my team is just trying to update the support pack as well.
Okay.
SP12. So when we look at the reading data from RAM, so when we read the data from RAM, the performance will be faster compared with reading data from disk, right? Let's see the second one, SQL console. So when we look at this diagram, right? So here, when we compare with the traditional model, there is some background echo coming, just I'm keeping it as mute. Okay, that's fine. So when we look at SQL console, basically in HANA we use a SQL language here. So also our language is also supported by SAP HANA. So when we look at the traditional model, right? So whatever the logic we write, so we are going to write in the application layer. Let's copy this. Right? So whatever the logic we are writing, so we'll be writing in the application layer, the code, everything. And when we look at here, so let's take an example. So if I am running a report for the selection of 2015, and let's take, we have a 10 million records, right? And let's take, we have a filter with the document type. So ZTRC and ZRES. So let's see, we have a filter on document type with the ZTRC, ZRES and ZTR. So when we look at the traditional model, so whenever I am executing the selection with the 2015 and we have a 10 million records in the database, that means the request goes to the database. From the database layer, it gets all the 10 million records from the database layer and send it to the application layer. In the application layer, due to the logic written in the application layer, let's take, we have a filters with only, I want to retrieve the data only with these 3 document types. So after filtering, so we got only 1 million records for output. Right? So we got only 1 million records. That means if you compare this logic, so why we need to retrieve all the 10 million records from the database layer to the application layer? From application layer, due to the logic written in the application layer, we are displaying only 1 million records for output. That means So here we are having a bottleneck, right? So why we need to get all the 10 million records here from the database layer to the application layer, and we are only getting. So here we are having a bottlenecks. Let's see if you are having a selection of 2011 to 2015, right? So if you have 100 million records and it gets 100 million records, out of that we get only 5 to 10 million records. Why we need to get all the huge volume of data from the database layer to the application layer, and after filtering we are deciding for output. So here the performance is degraded a lot when we compare with the traditional model. Why? Because so we are getting a huge volume of data from the database layer to the application layer. The same thing when we look at SAP HANA front, right? So in the SAP HANA front, so here whatever the logic, right? So we are going to push down to the database. In SAP HANA we are going to create the views, right? So here we are going to create the views, attribute view. Second one is analytical view. And the third one is calculation view, right? So in HANA we are going to create the views, attribute views, analytical views and calculation view. When we say attribute view, which represents the master data like customer, which is of KN1, customer, material, product, all these are the master data tables. When we look at the analytical view, which represents the transaction data, like we have a VBAK, all these are the transaction data tables. So when we look at calculation view, it's a combination of attribute views plus analytical views plus tables as well. That means on top of master data tables, we create an attribute view. On top of transaction data tables, we create an analytical view. Let's see if my requirement is with master data, I go with attribute view. And if my requirement is with only with the sales, then I can go ahead, create an analytical view and I can go with reporting. Now if my requirement is both all the three areas like sales, delivery and billing, in those cases I go with the calculation view, right? So in BW terminology, when we say attribute view, which is of master data, and analytical view, which is of info cube or DSO, and the calculation view, which is of info set or multi-provider, right? So here what happens, whenever we create any views, by default these views are converted to the SQL in the database front. Let's take the same example of SAP HANA here. So here I am trying to execute the selection for 2015 and we have a 10 million records. So what happens? So whenever I run a query, a request goes to the database layer due to the logic written in the database layer. So whatever the logic we written in the database layer, so it searches for all the 10 million records and fetches only 1 million records for output. Right? That means whatever the logic we written in the database layer, so by default all the logic will be filtered in the database layer and only 1 million records will be sent from the database layer to the application layer, right? So that means only the transferred records we are going to move from database layer to the application layer. But when we look at the traditional model, all the 10 million records we are moving from database layer to the application layer. But when we look at SAP HANA, so we are moving only 1 million records from the database layer to the application layer, so that the performance will be faster whenever we look at compare with any other traditional models, right? So when we look at here, moving calculations to the database layer eliminates the need of transfer of large amount of data from database to the application, right? That means we don't need to move all the data in the HANA system. So only the selected particular records will be moved from database layer to the application layer, right? And we'll see the next one, which is of columnar store in SAP. So this is very, very important. So when we look at the columnar store in SAP HANA, right? So SAP HANA supports three type of tables. So one is the row store table and column store table and the table types, right? So SAP suggests always to go with the columnar store because of its advantages. We'll see what are the advantages. When we look at the data storage front, so the row store and column store where we are going to store the data, and the table type, basically this is used for parameters. When we go for any coding, right, so we do a parameters, right, so like customer number equal to varchar, or customer number equal to customer name equal to varchar, whatever the length. So those type of parameters, whenever we are declaring in the SQL, so those parameters are used in the SQL, declared in the table type in the SQL, and this table type will be used in the procedures. Procedures means it's nothing but a function models in SAP. Once we create a function model, those function models can be used in multiple programs, right? The same way that here the procedures, once we create a procedure, these procedures can be used in multiple calculation views, that means scripted calculation views. Okay, let's see this when we go for SQL in detail. And the next one is columnar store. Let's go with the columnar store. So let's take a simple scenario. So how the data is going to fetch from the read data from the row store, and how the data is going to read from the column store. So here when we look at the row store, it stores the table records in the sequence of rows, and the columnar store, it stores the records in the sequence of columns, right? So let's take a small example here. So we'll take once again the same thing when we are done with the architecture in detail. So when we look at here, so we have a table with the country, product and sales. We have a country India, Germany, US, and chocolate as product is all these fields, and we have a sales, right? So let's see if I want to display list of products for my output. So how it is going to handle with the row store, and how it is going to handle with the column store, right? So if it is of row store, so if I want to display the list of products, first it go with the row 1, it goes for India, chocolate and 1000, and displays the chocolate for output. And again it go with the row 2, it go to the India, ice cream and 2000, and displays the ice cream for output. And next it go for row 3, it go for Germany, chocolate and 4000, and displays chocolate for output. And go for row 4, US, noodles and 500, displays noodles for output. That means whenever we look at the row store, it's going to read each and every row and finally displaying for output. That means, so if you have a 10 million records, that means it's going to read all the 10 million records and display for output. But when we look at the columnar store, right, so here the data will be stored in a column wise. So when we look at the country, we have a India, Germany and US. These we call as a one column or a tuple, right? And product, we have a column like chocolate, ice cream, chocolate and noodles, or we call this as a tuple. And sales, we have one tuple. So if I want to execute the list of products, right, it directly go to the tuple which is a product and displays chocolate, ice cream, chocolate and noodles for output. That means, so whenever we go with the columnar store, the performance will be faster. Why? Because so we are going to directly hit with the tuple or the column and displays for output. So we don't need to read other columns. If you have, let's see, if you take a VBAK table, so we have almost 150 to 200 fields, right? So if you want to retrieve only 1 or 2 fields or 4 or 5 fields, so we don't need to read entire data. So we can read only that 5 fields and display for output. Rest of the fields, it will be ignored when we look at the columnar store. The same case here. So we don't want to read the country or sales data. We can directly go to the tuple which is of product and displays for output, so that the performance will be faster. Let's take the same scenario, one more scenario example here. So here we have a table like order, country, product and sales, and I want to display the list of, in the product I want to display only with the con with the sum of sales, right? So if it is of row store, what happens? Only I want to display con with total sum of sales. So if it is of row store, what happens? It go with the row 1, it identifies the con and stores in some internal buffer table, and it go for a row 2, and again it go for a row 3, it identifies the con and stores in internal table, and again it go for a row 4. That means, so once the all the search is done with all the lines, then finally it displays with con with sum of 1600. So when we look at the row store, it's going to read all the rows and finally display for output. But when we look at the columnar store, right, it directly hit to the tuple which is of product. So it goes search for the con and con and displays for output, so that when we read directly the tuple, the performance will be faster, right? So let's see how the data is going to store for country, or let's take a con, or let's take, if you take a country, let's take the example here. So how the data is going to store, either product or country or order, whatever might be, so how the data is going to store. So when we look at this scenario, okay, so when we look at this table, right, so whenever we store any table, let's take, we are taking as a VB KNA1 or whatever might be, let's take the KNA1, let's take this as a customer master data or any table. So how the data is going to store in a table? When we look at the row store, it's going to store like a same format which consists of rows and columns, which is going to read with the row wise. Let's see how the data is going to store in the form of country, right? So when we look at the country, so the system for individual row, the system will automatically convert with the 3 tables. So one is dictionary index, and next one is compressed column, and the third one is inverted index. So when we look at the dictionary index, right, so whatever the data, all the data will be stored in the dictionary index in a alphabetic order. Like we can see here, first letter starting with the Belgium, then D, F, and I and span. So that means it's going to store in an alphabetic manner. And also, if there is any repetition, if you look at the table, main table, which is of country, right? So we have Denmark, which is repeated, and one more Denmark, here also it is repeated, 2 times repeated. But in the dictionary table, it is going to store only one place, right? And Italy, we can see it is repeated with the 3 places. Here we have Italy, and here we have Italy, and here we have Italy. So here we are storing only 1 places. Let's take if we have a 10 million records, right? So let's take, we have 10 million records. Okay, so how many places do the country will store if it is the dictionary table? So how many countries we have? Almost we have 180 some plus, right? So that means when you look at the dictionary table, it's going to store only 180 places out of 10 million records or 100 million records, whatever the count. So it stores only 180 places in that dictionary table. That means, so when we look at the column store, more compression can be possible here. That means, so when we look at the column store, more compression can be possible. So when we are looking at going with the columnar store, this is one example for more compression can be possible. Coming back to the topic, so here the system will be stored in a dictionary table and compressed column and inverted index. When we look at the dictionary table, it will be sorted order, as well as, so it will be whatever the repeated, so it will be storing as a only one column here, right? And when we look at how the system is going to read it, right? So we have a compressed column and the inverted index. Let's see the compressed column, right? Here when we look at order for any table, the system will allocate a number for every table. Okay, let it be. So 1, 2, 3. Okay, the system will automatically allocate a number for these, any of these table. Let's take this, it will not allocate, but here system will generate automatically a numbering for compressed column. So let's take example here. So when we have here, we have totally 8 rows. So the system will create a dictionary table and the compressed column. The system, when we look at the compressed column, the system will allocate the numbering till 1 to 8. So let's see if the system want to read the data, how it is going to read. Let's see how the data is going to store in the database. So if you look at the row 1, so what is the row 1 here? Row 1 is 456, right? Row 1 is 456. So when we look at the row 1, right? So where it is storing at number 3. So the compressed column in turn look into the dictionary table, right? What is here we have? We have a 3 is a France. That means, so whatever the row 1, right, and the value is 3, that will be a France. When we look at the row 1, what is the value here? This will be the France. And when we look at the number 2, so what is the data we have? We have a 4, right? So when we look at the 4, it goes to the 4, right? So that means in the 4 number, in the 4, the data is Italy, right? When we look at the 2, what is the data we have here? Italy, right? And if you go with the compressed column with the number of 3, what is the data here we have? We have a numbering as 5. When we look at the 5, when we compare with the dictionary table, what is the 5 we have? We have a Spain. That means, so number 3, we have a 5 here, which is of Spain. When we look at the number 4, we have the data as 4. When we look up with the dictionary table, what is the 4 we have? We have a Italy. That means for 4, we have a Italy. And 5, we have taken as a 2. For numbering of 5, we have a 2. What is the data here for 2? Which is of Denmark. For 5, the data will be Denmark. The same way, 6 also we have a 2 as a number. So we have it compares with the dictionary table. What is the 2 here? We have a Denmark. For 6, we have a 2 which is of Denmark. In this manner, whatever the data, so it's going to look up the compressed column in term will look up with the dictionary table and displays for output, right? And when we look at the inverted index, so whatever the repeated columns, all these repeated columns will be available in the inverted columns. So these numbering will be compared with the dictionary table. So when we look at 1, 2, 3, 4, 5, and here we have a dictionary table will be 1, 2, 3, 4, 5. So what is the number here? We have a 1, and what is the value here? 7, right? So when we look at the 7, right? So so in the row 1, so 1 we have a 7. 7, what is the 1? 7 place we have a 1 here. Just give me a second. Okay, sorry. So when we look at the inverted index, we have a value is 1. So when it compares with the dictionary table, what is the value here? 1. So it's a Belgium, right? Value is 1. Which place it is storing? In the number 7. So we go compare with the compressed column. What is the number 7 here? 1. So 1 is which is of France, right? Not France. Sorry, it's a Belgium. Just give me a second. Belgium is stored in the number 7, right? So the same thing. So when we look at the 1 here, so we have a 7 as a value. The inverted index will look up to the dictionary table. So what is the 1 here? The 1 Belgium. Which place it is going to store? In the place of 7. So if you look at the data, so 1 Belgium, which is the place it is going to store in the number as a 7. And if you look at the number 2, so 5 and 6, it's going to look up to the dictionary table. So what is the dictionary table? Number 2, we have a Denmark. When we look at the Denmark, number 2 is looking up to the dictionary table which is of Denmark, which all the places Denmark is storing 5 and 6, right? So if you look at the 5 and 6, the Denmark is storing here, right? 5 and 6 places the Denmark is storing. So when we look at the 3, it's look up to the dictionary table. So what is the 3 here? We have a France. France is storing in the number in first place, so right? So it goes to the France here, right? And when we look at the number 4, right, in the dictionary table we have a number 4 is Italy. Italy is storing which all the places? In the 2, 4 and 8. It goes, we are storing, it's stored at 2 Italy, and 4 we have Italy, and 8 we have a Italy. That means 2, 4 and 8 places we are storing with the Italy, right? That means here also we can see compare. The system will also, if you compare with the inverted index with the compressed column, so here also we can see 7. What is the number 7 here? It's in the, 1 second. Okay, that's fine. So the inverted index we can compare with the dictionary table, so and we are able to see. When we look at the 4, we are storing at 2, 4 and 8. So when we look at the 2, 4 and 8, so you can see you can also compare with the compressed column. So we have a number as 2 and 4 and 8. The 2, 4 and 8, whatever the data is the 4. So what is the 4? We have a Italy. It looks up to the dictionary table and displays for output. Italy 2, 4 and 8. So that means this is how the data is going to look up the data and display for output. But we have a question here. So when we look at the column store, right? So we are storing in only one column. But here when we look at the compressed column, right? So when we look at the columnar store, so the data we are splitting into 3 tables. So does it degrade the performance or improves the performance? What do you say, Ramesh? So since here we are using only one column, so we are splitting to 3 tables, right? So does my performance will be improved or not?
Yes, it will be improved when there are millions of records, but if you have only one record or 10 records, that this doesn't make sense.
Okay. So that case, whatever we are saying, so if it is of like, let's say if you are taking a country, we are taking a country, more compression is possible so that the performance will be improved. If you take an order number, what happens here? So there will not be any repetition of here.
Right. Any order number will be anyway, yeah. It depends on what we are looking at, right? So
yeah. The main thing is here is right. So here we are using the numbers instead of alphabetics. The first thing is more compression can be possible, and the second thing is instead of alphabetics, so we are using the numbers. When we look at compare with the numbers, right, storing the data in the numbers with the zeros and ones will take very less bits of data compared with storing the data with the alphabets, right?
And even memory and also maybe speed also.
Yeah, if you look at 1 bit, bytes and bits, okay, 1 bit, a single digit, either zeros and one.
It depends on how big that number is, right? Alphabets 2 characters, right? I mean 1 character means 2 bytes.
Yes, yes.
So and if it is a number, right, it's a different one. 1 byte. So numbers are always less memory than.
Yes. So this is one of the reason when we compare with alphabetic with numbers. When we look at the numbers, it takes lesser space. Now alphabetics. Okay, and okay. So this will be the columnar store. When we look at the columnar store, more when we look at here, only the first one is the when we look at the advantages of columnar store, only the affected columns will have to be read during the selection process of the query. Any other columns can serve as a index. That means only that particular tuple will be selected at the runtime, so that the performance will be faster when we go with the columnar store. And the second one is better compression. When we look at the columnar store, more compression can be possible when we compare with the row store. And also we have a better parallel processing. So in the columnar store, data is already vertically partitioned. This means that operations on the different columns can be easily processed in parallel. That means, so here we have a different engines here. So let's see if multiple columns need to be searched or aggregated, each of these operations can be assigned to different processors or cores. In SAP HANA, so when we look at the hardware innovations, right? So we have a different cores where each core can handle into a different jobs. So when we look at the hardware innovations, so this is one of the medium scale clients, so which I have taken an example. So here, what is this hardware sizing, right? So if you look at here, for one multi-core CPU consists of 10 cores. That means, so here when we look at cores, different cores, each core can handle different jobs, right? So when the different core can handle different jobs, the processing will be faster whenever the data is split to multiple cores. Let's take this concept and we'll wind up the today's session. So when we look at this diagram, so when we look at the hardware innovations, so we have a multi-core CPUs. So if you want to looking for a sizing all those documents, I'll share you the documents. Okay, how do that this sizing will be taken care by the admin guys. Hardware sizing, all those things. Right. So when we look at this one of the appliance, so here for one multi-core CPU consists of 10 cores. Okay, so each core can handle to multiple jobs. So one multi-core CPU can handle to 10 cores. That means, so one multi-board CPU consists of 8 CPUs or 8 multi-core CPUs or multi-boards. That means, so one multi-core CPU consists of 10 cores. That means 8 multi-core CPUs consist of 8 CPUs. Boards consist of 8 CPUs. That means, so for one multi-board CPU consists of 10 into 8, 80 cores when we compare with one multi-CPU board. That means when we look at one CPU, multi-core CPU consists of 10 cores, then one board, multi-CPU board consists of 8 CPUs. That means 10 into 8, so we will be having 80 cores when we look at multi-CPU. One board consists of 80 CPUs, right? And let's assume, so if you have it 4 TB of RAM, right? If you have a RAM of 4 TB of RAM, so that means, so it counts to 80 into 4, it counts to 320 cores or more for one system. This depends on the client. The client can go ahead and increase multi-CPU boards. They can go ahead and increase the multi-CPU boards based on their requirement. This is one of the basic scenario. That means each core can handle with multiple jobs. If you have a 220 cores, that will be more performance will be available. But when we look at our laptops, right, so we have only a dual core or 4 core. Now we have something 8 core, 16 core should be something now. But when we look at SAP HANA, so we are using almost, this is one of the small cap client which we have taken as an example. So one multi-CPU board consists of 10 cores and one multi-CPU board consists of 8 CPUs. That means, so one multi-CPU board consists of 80 cores. That means if you have a 4 TB of RAM, so that counts to 80 into 4, that counts to 320 cores or more. That means, so if you have a 320 cores or more, the performance will be too faster when we look at the SAP HANA hardware innovations, right? So you can see in a columnar store, data is already vertical partitions, all those things. If multi-columns need to be searched or aggregated, each of these operations can be assigned to the different processor or cores. So if you have a multiple cores, the performance will be also faster, right? This is hardware. I'll just share you the document more about this. Just you can go through that. Okay.
Will you share this document also, whatever you are going through?
Only the demo document I'll not be sharing. So you'll be getting all those things when we look at the architecture also. So with the explanation. So when we look at the architecture, so you'll be getting all those things. So it was updated here, right? Whatever the RAM. So I have a latest one. So I'll just show you. There was a logo in that. I'll remove it and I will add it. Okay, whatever the architecture, everything I have updated here. So I have one more document. So I'll just I need to remove the logo. I'll just share that document too. Okay, so which was recently done. Okay, and tomorrow next class and when we look at here, so these are the SAP provided PDFs. So SAP have tested for few of the clients, right? This is one of the banking sector, so where they have loaded data for 30 days, and so before implementing SAP HANA, so they were having a traditional DB for 1 month. The data is coming for 41.9 GB of data is coming to their system. So after implementing to SAP HANA, so they have tested. So after implementing SAP HANA, so once doing the columnar store, you can see data after doing a columnar store, data will be automatically compressed. So once the data is compressed, it's only storing with 6.6 GB of data when we go with the columnar store. When we look at the row store, that means more data space will be available for the client. So if they go with SAP HANA, also if the client nowadays clients are bothering, they're getting huge volume of data. So when there is database size is full, what happens? They need to keep on extending their size, and that will incur to the additional cost for the cost or burden to the client, right? So when we look at HANA, so there will be more data compression can be possible when we are looking at HANA. So this is the earlier version. It's taking only 41.9 GB. So after implementing HANA, so it came down to the 6.6 GB of data. And also when we look at performance front, so we have in-memory technology or the SQL console or columnar store or the hardware innovations. All these factors together made SAP HANA as one of the powerful tool. And also when we look at the reporting front, right? This is earlier, we can see even if you look at the SAP BW or some clients before 5 years, 6 years back, so the clients used to run the query, they wait for 15 to 30 minutes and they go out after 15 minutes, they come and see the reporting, right? So this has happened earlier like 5 to 6 years back. So later SAP BW tried many performance tunings, everything, but when we look at the HANA system, the performance is too faster when we look at traditional model. It's taking almost 2660 seconds in the traditional model, but when we look at HANA system, it's taking only 5.1 milliseconds. That means SAP says always it's 100 to 200 times faster when we go with the performance of the query. They have tested almost for 70 retailers and they have tested for 460 billion records and 50 terabytes of data. They were able to execute in 0.04 seconds on any device, anywhere, any time. So the SAP says like depends on the system, it's almost 20 to 200 times faster when we compare with the any other systems, right? And tomorrow we'll go ahead with these concepts, additions, and all these things are scenarios, and let's go with a little bit of replication in detail, and we'll just jump into the first half an hour. We'll take this, and second half an hour we'll get into the system. Okay.
Okay.
We'll see all the options available in the system. First half we'll go with theoretically, and second half we'll go with the system, and we'll see the options over there, right?
Okay.
So tomorrow we'll meet at 7 a.m. IST then.
Right.
Okay.
So how about system access?
So you'll be getting, I don't know, 2 months or 3 months access. Just you can contact to the SBR trainings. So we'll be getting with the latest version of SAP HANA, which is of SP11.
Okay, I'll talk to them. That's fine.
Okay.
All right. Thanks for
Okay then. Yeah. Have a nice day. Take care. Goodbye.